In this video, we're gonna learn to set up partial fractions when you have distinct linear factors. So your first step in any problem that involves partial fractions is to recognize which case you are dealing with so that you can solve the problem. The simplest case in which partial fractions are helpful is when the denominator is the product of distinct linear factors. So for example, you can change this x over x plus 4 times x minus 7 to a over x plus 4 plus b x minus 7. Keep in mind that for each distinct linear factor in the denominator, you need to add a partial fraction of the following form. For example, suppose that you want to integrate the following rational expression 1 over x times x plus 2 x minus 5. The denominator is the product of three distinct linear factors such that x, x plus 2, and x minus 5. So it's equal to the sum of three fractions with these factors as denominators. So a over x plus b over x plus 2 plus c over x minus 5. The number of distinct linear factors in the denominator of the original expression determines the number of partial fractions. In this example, the presence of three factors in the denominator of the original expression yields three partial fractions. To find the values of the unknowns a, b, and c, first get a common denominator on the right side of this expression. So 1 over x times x plus 2 x minus 5 is equals to a x plus 2 x minus 5 plus bx x minus 5 plus cx x plus 2 all over this denominator x plus 2 x minus 5. So now multiply both sides by this denominator. 1 is equals to a x plus 2 x minus 5 plus bx x minus 5 plus cx x plus 2. So to find the values of a, b, and c, substitute the roots of the three factors 0, negative 2, and 5. So 1 is equals to a, 2, negative 5. So a is equals to negative 1 is equals to b, negative 2 minus 5. So b is equals to 1 over 14. In here, 1 is equals to c times 5. 5 plus 2. C is equals to 1 over 35. So plugging these values back into the original equation gives you negative 1 10x plus 1 over 14 x plus 2 plus 1 over 35 x minus 5. So this expression is equivalent to what you started with, but it's much easier to integrate. To do so, use the sum rule to break it into three integrals, the constant multiple rule to move fractional coefficients outside each integral, and variable substitution to do the integration. So let's integrate. Negative 1 over 10x plus 1 over 14x plus 2 plus 1 over 35x minus 5. dx. So it will become 110 ln x plus 114 ln x plus 2 plus 1 over 35 ln x minus 5 plus c. So this would be the final answer. So let's have another example. So let's evaluate integral of 3x plus 11 over x squared minus x minus 6 dx. So the first step is to factor the denominator as much as possible and get the form of the partial fraction decomposition. Doing this gives 3x plus 11. So factor this out. X minus 3, x plus 2. So it's equals to a over x minus 3 plus b over x plus 2. So the next step is to actually add the right side back up. 3x plus 11 over x minus 3 x plus 2 is equals to a x plus 2 plus b x minus 3 over x minus 3 x plus 2. We need to choose a and b so that the numerator of these two are equal for every x. To do this, we'll need to set the numerators equal. So 3x plus 11 is equals to ax plus 2 plus b x minus 3. So note that in most problems, we will go straight from the general form of the decomposition to this step and not bother with actually adding the terms back up. The only point to adding the terms is to get the numerator, and we can get that without actually writing down the results of the addition. So what we're going to do here is to notice that the numerators must be equal for any x that we would choose to use. In particular, the numerators must be equal for x. For x is equals to negative 2 and x is equals to 3. So let's plug this in and see what we get. So 5 is equals to a, 0 plus b, negative 5. So in x is equals to 3 here and here. 20 is equals to a, 5 plus b, 0. So by carefully picking the x, we got the unknown constants to quickly drop out. Note that these are the values we claim they would be above. So at this point, there really isn't a whole lot to do other than to integral. So let's integrate this. 3x plus 11 x squared minus x minus 6 dx. So it's equals to 4x minus 3 dx minus integral of 1 over x plus 2 dx. So the answer would be 4 ln x minus 3 minus ln x plus 2 plus c. So this will be the answer. So that's a wrap. Hope you learned about the distinct linear factors. Thank you.
We will be discussing about repeated linear factors. Your first step in any problem that involves partial fractions is to recognize which case you're dealing with so that you can solve the problem. One case where you can use partial fractions is with repeated linear factors. These are difficult to work with because the repeated factor requires more than one partial fraction. We can identify a repeated linear factor if a certain factor in the denominator occurs more than one. For example, let's solve for the integral of dx over x times x plus 2 squared. We can see that the factor x plus 2 was repeated 2 times. If that is the case, we should factor it as x times x plus 2 times x plus 2 squared. After making it into this form, we will multiply it by the denominator so that we can cancel out the other factors, which will give us an answer of 1 is equals to a times x plus 2 squared plus b times x plus 2 plus cx. With this, we can get the values of a, b, and c by substituting each of the variables by each of the roots of the factors. First is the factor x is equals to 0. By using the root of x, which is 0, we can get the value of a, which is 1 is equals to a 2 squared is equals to 4a we can get the value for a, which is 1/4. And then we'll substitute it for the other root, which is x is equals to -2. This will lead us to get the value of c, which is -1/2. And the other root, which is x is equals to 1, this will lead us into getting the value for b, which is -1/4. Plus times 2 minus 1/2 plus 2 plus 14 plus 3 halves 9/4 2. After getting the values for a, b, and c, we can now substitute these values into the equation that we made a while ago. This will make us have a 1/4 integral of dx over x minus 1/4 integral of dx over x plus 2 and minus 1/2 integral of dx over x plus 2 quantity squared. Now with this, we can already integrate it directly, which will give us an answer of 1/4 ln x minus 1/4 ln x plus 2 plus 1/2 x plus 2 to the power of -1 plus c. Now let's solve for another problem, which is integral of x cubed minus 1 over x times x plus 1 cubed dx. Now we will just repeat what we did in the last problem by copying this x cubed minus 1 over x times x plus 1 cubed is equals to the four factors, which is a over x plus b over x plus 1 plus c over x plus 1 quantity squared plus d over x plus 1 quantity cubed. And then by multiplying it of its factors, we can get an answer of x cubed minus 1 is equals to a times x plus 1 plus b times x plus 1 squared plus c times x plus 1 plus dx. And by multiplying it with its factors, we can get an answer, which is x cubed minus 1 is equals to a times x plus 1 cubed plus b times x plus 1 squared plus c times x plus 1 plus dx. And now we will try to expand these functions and we'll distribute the unknowns to the functions we expanded. Okay, so x cubed minus 1 a and x plus 1 cubed will be x cubed plus 3x squared plus 3x plus 1, and b will become x times x squared plus 2x plus 1, and c will be x squared plus x plus dx. Then we will expound it further, which will be a x cubed plus a 3x squared plus a 3x plus a plus b x cubed plus b 2x squared plus bx plus cx squared plus cx plus dx. Now we will group these into same coefficients and variables, which will be a times x cubed plus bx cubed plus a 3x squared plus b 2x squared plus cx squared plus a 3x plus bx plus cx plus dx and plus a. Then we will find the values for a, b, c, and d. And starting with a, we can see that a is a constant and we have a constant in the other side. So a will be automatically equal to -1. And then we will solve for the value of b. And in here we can see that ax cubed plus bx cubed had a same variable with the same degree on the left, in which we can say that a plus b is equals to 1. Now that we have the value of a, which is -1, we can directly substitute it into this equation, which will be -1 plus b is equals to 1. And then we will have a value for v, which is 2. And in finding c, we can see that in this function, in this equation, we already have the values for a and b, which only lead to c, which is our only unknown, rather than in this equation that has two unknowns. Now, we should use this equation: a plus b plus c, and you can see that its variable x squared is nowhere to be found in the left side. We can say that a plus b plus c will be equal to 0. Now that we have the values for a and b, we can also directly substitute it to get the value for c, which is, we should also not forget to include the constant, which can be seen on the equation, which is 3, 2, and 1. Now that you have included the constant, you can now directly substitute it with the a and b, which will give us an answer of 3 a plus 2b plus c is equals to 0, negative 3 plus 4 plus c is equals to 0, and c would be equal to negative 1. Now that we have values for a, b, and c, all that is left now is to solve for d. We can use this function in order for us to get the value for d. And then we will write it as 3a plus b plus c plus d equals to 0, since x won't be found in the left side. And now, after doing this, we can also directly substitute it, which will lead to our answer. 3 times negative 1 plus 2 plus negative 1 plus d is equals to 0, and it will lead us to an answer of d is equals to 2. Now that we have the values for a, b, c, and d, we can already substitute these directly into our equation, which will make us have integral of dx over x plus 2 integral dx over x plus 1 and minus, since c is equals to negative 1, integral of dx over x plus 1 quantity squared plus 2 integral of dx over x plus 1 cubed. By the way, we should also not forget the negative sign on letter A, because a is equals to negative 1, so we should put negative to the integral of dx over x. So now that we have already substituted the values for a, b, c, and d, we can directly integrate it and have the answer of negative ln x plus 2 ln x plus 1 plus 1 over x plus 1 minus 2 over x plus 1 squared plus c. That is all for partial fractions distinct linear factors. Thank you for listening, and I hope you've learned something from it.
In this video, we will about to discuss about integrating using partial fractions when the denominator contains irreducible quadratic factors. You can use the partial fractions method to integrate rational functions, including functions with denominators that contain irreducible quadratic factors, that is, quadratic factors that can't be broken up into linear factors. The basic idea behind the partial fraction approach is an adding a fraction. For example, 1/2 plus 1/3 is equals to 5/6. So you can split up 5/6 into this one. Only you're dealing with complicated rational functions, not ordinary numerical fractions. You can use the partial fractions technique for functions whose denominators can be factored down to linear factors. However, using this technique is a bit different when there are reducible quadratic factors. Now let's go to the actual problem. Let us integrate 5x cubed plus 9x minus 4 over x times x minus 1 times x squared plus 4 dx. Step 1. Factor the denominator. But as we can see, the denominator is already done and already factored. Next, break up the fraction into a sum of partial fractions. So, as we can see, if you have an irreducible quadratic factor like the x squared plus 4, the numerator for that partial fractions needs two unknowns in the form ax plus b. So 5x cubed plus 9x minus 4 over x times x minus 1 x squared plus 4 is equals to a over x plus b over x minus 1 plus cx plus d over x squared plus 4. Next step, multiply both sides of this equation by the left side denominator. So 5x cubed plus 9x minus 4 is equal to a x minus 1 x squared plus 4 plus b x squared plus 4 plus cx plus d cx plus d times x minus 1. Next step, take the roots of the linear factors and plug them one at a time into x in the equation from step 3 and then let us solve. Okay, so if x is equals to 0, then it will have negative 4 equals to negative 4 a, then a will result to 1. Next, if x equals to 1, so will result to 10 minus is equals to 5b, then b is equals to 2. You can solve for all the unknowns by plugging in the roots of the linear factors, so you have more work to do. Next step, plug into the step 3 equation the known values of a and b and any two values for x not used in step 4. Low numbers make the arithmetic easier. So to get a system of two equations in C and D. So A is equal to 1 and B is equal to 2. So if x is equal to negative 1, so negative 18 minus negative 10 minus 10 minus 2c plus 2d. So result of 2 minus equals to negative 2c plus 2d. Divide everything to 2, the result to 1 plus to negative c plus d. Next, if x is equal to 2, then the result to 54 is equal to 8 plus 32 plus 4c plus 2d. So 14 is equals to 4c plus 2d, and the result divide all to 2. 7 is equal to 2c plus d. So next, solve the system that is this one and that one. So if 1 is equals to negative c plus d and 7 is equals to 2c plus d, then c is equals to d minus 1, and this one is d minus 2c. So c is equal to 7 minus this one 2c minus 1. Then c is equals to 6 minus 2c. And then transfer this one to that. So the result 3c is equals to 6 divided to 3. C is equals to 2. Next, d is equals to 7 minus 2 times 2. Then 7 minus 4. D is equals to 3. Now let's split up the original integral and integrate. Using the values obtained in step 4 and 6, which is a is equal to 1, b is equal to 2, c is equal to 2, and d is equal to 3. And the equation from step 2. You can split up the original integral into 3 pieces. So the original integral is 5x cubed plus 1x minus 4 over x minus 1 times x squared plus 4 dx. Now the result to 1 over x dx plus integral of 2 over x minus 1 dx plus integral of 2x plus 3 over x squared plus 4 dx. And with basic algebra, you can split up the third integral above into 2 pieces, resulting in the final partial fraction decomposition. So 1 over x dx x over x squared plus 4 dx plus 10 over 3 x squared plus 4 dx. The first two integrals are easy. One-step natural logarithm integrals. So for this one, it will result to ln x plus ln copy that to ln x minus 1 plus this ln x squared plus 4. But for this one, for the last, we need to use the arctangent rule, which says integral of dx over a squared plus x squared is equals to 1 over a arctan a over x over a plus c. So the last one will result to plus 3 halves arctan x over 2 all over plus c. And this is it. This is your final answer. You can also answer ln x times x minus 1 squared times x squared plus 4 plus 3 halves arctan x over 2 plus c. You can also answer that. So here's your final answer. And that's it. Again, this video is about integrating using partial fractions when the denominator contains irreducible quadratic factors. That's all, and thank you.
Hi, in this video, we're going to talk about finding areas between curves. The basic idea is when you have two curves, for example, this one, we'll call this one f of x, and the other, this one, we'll call this g of x. And what we're trying to do is find the area between the two curves, this part. So here is the x coordinate of A and x coordinate of B. So the formula to find the area between curves is integral of A to B. So basically you take the top curve first, which is the f of x minus the bottom curve, which is g of x dx. So this is the formula that we're going to use in finding the areas between curves. So let's have an example. So the first given is y is equals to x squared minus 4x. So x squared, that means it's a parabola. So we'll put it this way. And then another given is 2x. And then our points of intersection are is at 6 and 12. and at the origin. So origin is 0, 0. So as I've said, x squared is a parabola, and the points of intersection are 0, 0, and 6, 12. So let's make a parabola. And then line y is equals to 2x. So from 0, 0 to 6, 12. Let's assume this is 6 and this is 12. Here and here. So what we're gonna do is to find the area in here. So we take the smallest coordinate here to the largest x coordinate for integration. So integration of, this is 0 and this is 6. So integration from 0 to 6. So you take this is the line on top, which is y is equals to 2x. This curve is y is equals to x squared minus 4x. So you write this first, 2x minus the bottom curve, which is x squared minus 4x dx. So now we'll just have to simplify this equation. Because these two have the same variable, so we just have gonna add them. So 2x minus negative 4x is 6x minus x squared dx. We integrate this, we get 6x squared over 2 minus x cubed over 3. So we can simplify this into 3x squared minus x cubed over 3. And we'll have to integrate this from 0 to 6. So now we'll have to plug the values. First, the upper limit, then subtract the lower limit. So this is the upper limit and then the lower limit. So 3 times multiply to 6 squared minus 6 cubed over 3. Then if you plug the 0 here, everything will just be equal to 0. So let's just put 0 here. And then the answer is 36 square units. So this is our final answer. Now let's have a little complicated example. The given are y is equals to 8 minus x squared, and the line x squared, then x negative 3, and x is equals to 3. So we can figure out the points of intersection by setting them equal to each other. This one, 8 minus x squared is equals to x squared. Then let's equate it to 0. So it's going to be 0 is equals to x squared plus x squared minus 8. They have the same variable, so we can write this as 2x squared minus 8. When we factor it out, we'll get 2x squared minus 4. We can still factor it out by 2 times x plus 2 times x minus 2. Now we have the x-intercepts of x is equals to negative 2 and 2 from this set of. Now let's put it in a graph. So x squared is a parabola, this one. Let's put it this way. Because it's positive, it's going upward. And y is equals to 8x minus x squared. Here we can see that x squared is negative, so the parabola will go down. Then we'll move 8 units up because 8 is positive. So let's assume this is 8 here. So we'll have a parabola here. It's going downward. And their intersection is at negative 2 and 2. But that's not the only integration we need to solve, because we still have an intersection here at here, negative 3, and here 3. So we'll find all this 3 areas. So now let's plug in the values. So let's write integral of from negative 3 to negative 2. So this is the top curve. So we'll write first the x squared minus the lower curve, which is 8 minus x squared dx. So you've noticed that these two have the same variable, so we can just add it up. It'll become 2x squared minus 8 dx. So let's integrate it. It will become 2x cubed over 3 minus 8x integral from negative 3 to negative 2. So let's plug in the values. Always remember to subtract it from the upper limit down to the lower limit. So 2 times negative 2 cubed over 3 minus 8 times negative 2 minus the lower limit 2 times negative 3 cubed over 3 minus 8 times negative 3 will get positive 4.67 square units. So this is the area that we're finding for this part. Now let's find the area in this part. So it's an integral from negative 2 here and positive 2 multiplied to the top curve, which is 8 minus 2x minus the lower curve, which is x squared. This is actually x squared in here, dx. So because these two have the same variable, we just have to add them together. It'll become 8 minus 2x squared dx. So when we integrate it, it'll become 8x minus 2x cubed over 3, integral from negative 2 to positive 2. So again, upper limit minus lower limit. So let's put number here. So 8 times 2 minus 2 times 2 cubed over 3 minus 8 times negative 2 minus 2 times negative 2 cubed over 3, and we'll get positive 21.34 square units. So this is the area that we're looking for in this part. Now let's find the area in this part. Let's use another paper for that. So this is the integral from 2 to 3. This one here is our top curve. So we'll have to write x squared minus the lower curve, which is the 8 minus x squared dx. Let's simplify it. We'll get 2x squared minus 8 dx. Let's integrate it. We'll have 2x cubed over 3 minus 8x integral of from 2 to 3. So let's put on the values. So again, upper limit minus lower limit. So we'll get 3 cubed over 3 minus 8 times 3 minus 2 times 2 cubed over 3 minus 8 times 2. And we'll get an answer of, we'll get positive 4.67 square units. So that is all for finding areas between the curves. I hope you've learned a lot about it.